be around it would be of 50 to 60 hours. It mixture of like both theory and lab. So once after the completion of the course, you can go for the exam. So basically, we start with very basics. This course is for anybody, like even if he's a beginner or if he doesn't have any knowledge in the cloud computing, we can start off that. You can start off from here. So basically, what I'm going to do is my structure of training would be, so we'll start with the cloud computing. So the definition of the cloud computing, what is cloud computing, and what are the types of deployment of the cloud computing, and what are the service models of the cloud computing. So once we cover these basics of the cloud computing, this is these three or the basics, three boxes are the basics of the cloud computing. We see the definition, we see the deployment models, then we what are the service offerings from the cloud, then we go to AWS Global Infrastructure, where we are going to study about the regions, availability zones, and edge locations. So one by one, we'll discuss on this thing. And then once we are done with the right-hand side, we move on to the AWS services, which is the core of AWS. Like EC2, somebody was mentioning to me EC2. So we do very deep dive into EC2 storage services, that is also called as an S3, simple storage services. VPC, it is all about the network. CloudFront, this is all monitoring tools. Route 53 is a DNS, and SNS, we call it as a simple notification service, which sends us some kind of a notification. CloudFront, which is again which is like content delivery network, and this is something identity access management. This is where we are going to talk about AWS security and the databases. So the order could be anywhere, but usually we start with EC2. So this is the whole high level picture of your AWS course. Okay, so we see what is cloud computing and deployment, so service models. Then we go to global infrastructure and to the services. So even if you're a fresher, if you do not have any knowledge on the cloud, or if you're just starting to learn cloud, you don't have to worry. So we take from the right from the scratch. Okay, is this clear? Any questions here
Yeah.
before I move into? Yes, can you? Hello, I'm audible, right?
Yes, you are audible.
Yeah. So any questions here on this one?
Yeah, hi. Is this course like completely specified to certification or like the
Yeah.
overall idea?
So that thanks for asking this question. So this is completely related to AWS Solution Architect, CS, I think SA 003. So we cover all the contents or topics which is prescribed by AWS for Solution Architect. Okay. So let me move on that. Okay. Uh, so earlier, this is the map of Microsoft data centers. This is a live map. This is a live location, or like what I can say is this is the live map of Azure data centers all over the globe. Earlier, even Amazon used to give this kind of information, but unfortunately, they stopped it due to some security reasons, or I'm not sure, but they say that because of some reasons they stopped it. So even AWS has similar kind of a setup. You can see here, right? Whatever the lights that you're seeing, these are the Azure data centers. Similar way, it was exactly AWS data centers was there. I mean, the map was available for us to view, but now it is not there. So now, when you're talking about Azure or AWS, so cloud computing, so it's something that nothing is there on the cloud. When you're seeing the word cloud computing, it doesn't mean that something is something present or something exists on the cloud. It is all what we are talking about is the data centers. Okay, so I think most of people know what is a data center. If not, please let me know.
No, I'm new to this field.
Okay, fine, thanks. See, what is data center is, okay, let me just quickly go through that. So before that, I wanted to show some figures that then we'll understand what is cloud computing. Before getting into the before getting into what is a cloud computing, on demand services, all this explanation, first let us understand what is a data center. So if you see this one, this is outer. So this is a data center, Amazon data center in the Los Angeles. Okay, so you can see this is the very big building wherein you have racks. In the racks, you have servers and network devices. So this is a big building, right? You can see this. This is one data center, one part of the data center in Los Angeles. Usually, AWS will not publish the data center images. I think for some reasons they have done this. So this is very big space, right? And what it will be there in the inside of a data center, a rack will be there. So it is a rack. These are the racks you can see, right? So in these racks, you have servers and you have network devices connected.
Okay.
Yeah. So this is actual figure of a inside a data center. This is the external data center. I mean, the outside from outside how it looks. But when you go into inside a data center, you have this one servers. You can see, right? These are the servers. These are the network devices, or it could be network devices and combination of the servers. Okay. So why we need a data center? Why we need a data center? So I'll give an example, like why we need a data center. I can't type here. Okay, let me show some of the figures. So this one, can you see this figure? Second figure.
Yes.
This is not coming. Wait, where is that figure has gone? Okay. This. So what I was talking about is this is a rack. A rack will be there. Inside the racks, the data center, all your servers, network devices, database servers will be installed. So these are the different data centers, how it look like. Okay. I want to show one more figure where how it racks will be. So this is one figure. So you can see exact copy of images. So these are all your servers or network devices. It could be servers or it could be network devices which will be installed in the racks. Let me go. So this is kind of a server. A server will be like Almara wherein you can push your server or network device inside and it will get and inside installed in these racks. Okay, so all your servers, network devices will be inside this racks. So whenever you're talking about Azure data center or any data center or any cloud computing, at the bottom level, the data center, it will be in a data center, and in the data center, you will find the similar kind of a setup, right? Is this clear? How a data center looks like? Like even when I'm talking about the cloud computing, Amazon data center, Azure data center, it is inside a data center. The picture will look exactly similar to this one. So this is the rack, one more picture. This is the rack where you have the components, network or server components are connected and you get an access to that. Whenever you're turning on, when you are launching your EC2 instances, right, it would be somewhere inside a data center. So what will be there inside a data center? A rack will be there. I mean, not one rack, there will be multiple racks. In that multiple racks, you have multiple services connected to each other. So you'll be launching an instance in any one of these server. I think the guys who are already working with EC2, they know that they'll spinning up the servers, they'll be turning on the servers. So whenever you're turning on the server, it will be inside these physical racks.
Okay, this
Correct
will
me if I'm wrong.
run 24 hours.
Yes, 24 bar 6 bar, 24 bar 7 bar 365 days.
Hmm. Okay.
See, I'll just give one more example.
It is like supercomputer.
No, supercomputer will does the calculations. So
Oh,
data center is a place where your all in IT infrastructure will be present. IT infrastructure means like your hardware boxes, right? Like tell me, I'll give one more example since you're all are from software, some or software background. Now what you see is a web page, right?
yes.
So it is how it has been how it has been made through HTML, CSS, JavaScript, React. These are the languages, the front end languages that has been used to create this web page. Correct?
Yes.
You must have heard front end, back end, and middleware, right?
Mm,
Back end is nothing but the database where it will store the data, right? The middleware is the logic, business logic, where it does some kind of a computation. Now, what I mean to say is the picture, the web page that you are seeing is in a front end. These images, whatever images are the data is present, it should be stored in the database. Now, where your middleware comes, the middleware or nothing, databases are three mainly. One is Oracle, SQL, that is SQL, NoSQL, that is NoSQL. These are the three prominent databases available in the market, used in the market. The front end I already discussed, HTML, CSS, JavaScript, React. These are some of the famous one. Now when you go to middleware, you see Java, Python, .NET, PHP, and Ruby. It's not PHP, the Ruby. So what happens, what is the function of the .NET or Java is that, like now I'm clicking on the electronics tab and I'm trying to do something, home theater or something. So here I'm performing some logic to display this kind of a things. When I'm clicking on satellite TV, so there is some kind of a computation or calculation is happening to get me this page. So how this is happening, the front end will request the database through the middleware. So Java comes into picture here to get the business logic for me. Okay,
okay.
so now in a nutshell, you understood what is a front end, what is a back end, what is a Java or Python developers will do. The Java Python developers take the request from the user, that is from the front page, and they get the calculation or the required output. Now, this application or this whatever you see, Amazon or your own website or your own application, where it will be installed, where it will be hosted, it will be not hosted on your laptop, right? It will be hosted on the server.
Yes.
So where are these servers? Those servers are inside a data center. This application will be hosted on any of these servers, not one server. It will be on multiple servers.
Okay.
Let me give one more example. The total number of how many servers WhatsApp will you have? Can you tell me? Imagine approximately how many servers WhatsApp is having currently on as on date? 50,000 servers. Can you imagine? The magnitude of a WhatsApp servers are 50,000 servers. And when you're talking about the server, you have web server, application server, and database server. Web server is nothing but your front end server. Like this is the front end server. These servers are different. Then the back end database servers are different. Then application servers are different, right? So these will be splitted into different services and servers, and they communicate with each other. That is at a very high level. I'm telling you. Now, where are these applications will be hosted? For example, this could be another application, this could be another application, this could be another program. These all will be hosted inside a data center, inside a rack, or inside a servers.
Okay.
Okay, so this is what a data center. A data center will hold a key component of IT infrastructure. When you're, it could be Amazon data center, or it could be IBM data center, or it could be Google data center. Every data center will look like this. Okay, so now I'll just quickly take down to what is a data center. So you get a yes, please. Somebody was saying something. Okay, so what is a data center? A data center is a place where your computer systems like network, storage, server will be there for your business requirements. So these are the some of the figures inside a data center. Okay. So this is very important before we learn what is a cloud computing, understanding the data center and why the people are now moving to cloud. You once you complete this modular, when I just finish off this presentation, you will understand more on that. So what are the data center? This is a place where you have your network systems, computer systems, server systems in place. Okay. So you can see here the core components of a data center are compute. Compute means nothing but your servers, storage, storage devices, which is required to storage your applications, network. You have multiple servers. So as I said, when you have thousands of servers, each server needs to talk to each other and talk to internet. So you definitely need a network, then application and DBMS. DBMS is nothing but your databases. Okay. Sorry. Okay. So I think it's something. So generally people think that data center will have only compute, storage, network, and database. But not only this thing, the data centers will also need a power and environment control, like air condition and fire suspension. See, so the cost, majority of the cost in the setting up a data center goes in the power consumption as well as the air conditioning and fire suppression. So it's not just network devices. We need to have power. We need to take care of air conditioning. We need to take care of fire protection. So I'll just quickly run through the core elements. Applications. See, for example, when you're seeing Facebook, Instagrams, Skype, or Airbnb, these are all the applications that we use in our day-to-day operations, right? Day-to-day life. Yes or no? Excel, PowerPoint, YouTube, so whatever I'm showing some few of the general applications that we use in our day-to-day life. So these are all will be in the our data center. Okay. So what is the function of the application? It provides some kind of a operations. When you give some input, it gives your output. That is nothing but your application. Who uses the application? The users. Users means ourselves. Like who uses the Facebook or Adobe or like Skype or Google Meeting or Gmail? We are the one, right? We are the end users. We use the applications. Is this clear? What do you mean by application? Guys, please speak out because I'm presenting my screen full screen, so I can't see who is there or not. Is it clear? Hello, is there? Okay, thank you. So what is an application? Application is you are just giving some input to get some output. So why are we using Excel? We want to do some kind of a task. So that is the reason we are using Excel. So that is one example of an application. Next we use compute. Compute is which in cloud computing or in data center technology terminology we call that as a server. We can call it as a compute. So the main compute means it will does the computation like our systems have CPU, memory, and storage, right? Our laptops have a CPU, right? Like 16 GB CPU, 8 CPU, RAM, and memory. Similar way, servers will also have the same thing, but at a very higher rate. So those things, the server at a data center layer or at a cloud computing, we call it as a compute. So what is the purpose of these servers? It runs applications and databases or something like that. Now DBMS is, I think most of us know, database management system where our data is stored. Storage, again storage devices, like storage devices or store our information or the data, which we can use it for later point of the time. The network, we have different servers, right? We have web server, application server, database server, storage devices, and users want to connect to our applications and our applications need to interact with the outside world. Then all together there should be some kind of a networking should be there. Without networking connection, without connection between them, then they'll not be able to communicate. So network is also a very important component when you're talking about the data center. So now we talked about the core components, what is network, storage, server, and DBMS. So same things which we are going to talk very detailed when we are talking about when we are going to study in AWS. So this is a typical data center which looks like this. See, this is where racks and where you can see these are the racks. The red ones are the racks where you have your servers installed. So then, if you see here, you have a generators, you have a cooling towers, you have electrical substation. So a data center will always consist of these components. Now I'll just quickly explain why we need a generator, why we need a cooling tower, and so on. This slide is clear? Okay. Now you see, somebody was asked me like what happens? It will run for 24 hours, 365, 7 days, 365 days. Yes, it will run for that. So I'll just show you one example. This is a server. Okay. Please see here. This is a one server. It is connected in one rack. It is placed in one rack. Let me write it in yellow. This is a rack. Inside rack, one my server is there. Okay. It has two power channels. PDUs means power data units. It has two power channels. I'll tell you how it will be, what is the reason to have two these things. So on the right hand side, you see power grid, generator, and UPS. So now by looking at it, this channel, this power point, like in how many ways it can get the power? Three ways. One is from the raw power, that is from the supply. It could be from anything. It could be from hydro plant or thermal plant or nuclear plant. It will get the power from that. This is one. For some reason, if this power fails, the generator will kick up and it will supply the power. So we have second source of power, and for some reason even the generator fails, we have a UPS to provide the power to this side of the rack. And just like now on the left side of the channel you have three power supplies, just in case just in case if all these three, I mean if there is a problem with the this side, and if everything goes down, similar kind of a setup will, the power will be there from the right hand side. This is a raw power, this is a generator, this is a UPS. So at any given point of the time, you don't see any power outage. And it will have two or more than two to three internet connections. So even if one connection fails, the internet will be always, the servers can always be reachable via other links. Now you see how much expensive or how much cost or how much effort will be required to not only build the data center, to manage and operate, right? It has got six source of power, so there is no chance of power outage or anything happening in that way. Okay, so this is how a typical rack will be there inside a data center. Here all the equipments will be there. So this is a back view, and this is a side view where it is all or the servers. These are all the servers which we can look at the front or side view, and this is at the back back of the rack. So here in these racks you can see these are the racks, these are the racks, these are the racks, these are the racks, this. So the layout will be similar to this, not exactly but almost similar to this. So here you can place IT equipment like your servers, network, storage, all the devices will be placed in these racks. So storage, servers, we just see electrical path, we just, so these are the utility transformers. So transformers are required to downgrade the power which you are getting from the raw supply. And this is ATS. ATS means automatic transfer switch. If this raw power fails, then this will kick on the generator to start running. So these are the generators that we see in a normal day life. This is ATS which will kick off if the power fails. So this is a transformer to upgrade or downgrade the power to the data center. So these are the inside. This is the electrical room where they manage the power. These are the battery rooms. It will be similar to this one, and this is a UPS. Batteries and UPS are different, right? So this is a UPS room. How big you can see the batteries. Number of batteries will be you can it will be countless. So the batteries to provide the electricity to the uh, data center in case power goes down. So these are the air cooled chillers to take the heat which is generated inside the data center. So cooling towers or pumps. Pumps is required to pump the chilled air into the data center so that whatever the hot air or some here noise that is produced inside the data center, it can suck that one. Okay, these are the chillers. So these are the mechanical units, air conditioning units. Okay, and the other thing is the floor. You see the floor. The floor of the data center will always 2 feet to 3 feet above, and there a platform will be built. So this is just a construction. On this construction, it is happening, and this is where it is completed. You know the reason why the data centers, all the racks will be placed on the raised floor because of two reasons. One is they'll pump the cool air from inside here, and second one will be you have to connect multiple servers, right? So the cables, all cables will come from the down. If cables you are taking on the floor, then there is a chance that if some cable can accidentally pulled out or somebody can kick the cable. That is the reason always all the data centers floor will be almost 2 to 3 feet height from the ground so that the cables can be laid underground. Not underground, I mean, cables can be laid under this floor. Okay, you can see here figure, right? So this is how typical. Now this is a raised floor, this is a rack, and in this rack, servers will be there. So you'll be standing and working on that, and below you, 2 feet, the cables will be coming and connecting to the your servers. Even the electricity, air conditioning, and the data cables, voice cables, everything will be taken in the down. So you can see here, this is how a typical data center looks. Any question, please? Okay. So why we need a chiller fans? So these are the air conditioned plants which supply chilled air to you to for absorption of heat. So again, this is a floor. As I said, chilled air will come from the bottom, and the hot air which is generated or developed from the server, it will be sucked from the top. Like I can give an example. Even when we cook in our house, the hot air will be taken by the this one, right? It will hot air will always go up. It will never go down, right? So similarly here, the hot air which is generated from the server, the servers, it will be taken from the top floor as roof, and then the cold air will be pumped from inside the ground to make it the device cool at the normal temperatures. See, imagine like your laptop, if you work for a 1 hour, it generates heat, right? But think about a server which is very big and which has to do so many calculation, how much heat it will generate. In a data center, you will not find one server. You find thousands of server. Even you cannot hear what other person is saying if he's just 1 meter far from you. If he's talking, you'll not be able to hear because so much of noise and so much of sound will be there inside a data center. So fire protection, because these are the one of the components which will be there in the data center, because fire, it could be due to electrical or it could be to the air condition. If any fire happens, so these are the fire extinguisher will be available at data center to mitigate any fire things. So these office spaces, the people generally needed to manage and maintain this whatever we discussed. And this is one network operation center where the technicians will be sitting and managing those devices. So security, as you know that you have this perimeter security and authorization, and once only when you have authorization to enter the data center you can enter it, until you have a pre-authorization you cannot enter into the data center. So that way they are providing the security. The fuel oil, why we need a fuel oil? To run a generators we need oil, right? So these are the fuel pumps or fuel tankers which is will be available very near to your data center to supply oil. So then badges and biometrics. So this all, like you should have the proper credential in order to enter into a data center. It could be your ID card, it could be your fingerprint, or it could be your signature. So there is multiple ways, multiple procedures will be implemented on the security front. So water storage. So this is all why I'm telling about this is now you got some idea about the data center, right? Please say yes or no. Hello. Yes, please speak out. So now you have seen how big is a data center and how much time or how many people needed to maintain that one. Not only that, to build one data center, the capital cost investment, it's a huge, right? And the space required is huge. Not only space required, power is required, air condition is required. You need a qualified people to manage that thing. So it will be a lot of cost on the organizations to maintain one data center. Let me take one bank, any bank like HDFC or ICICI. What is the core of their business? Their core business is finance. Their core business is finance related. So they need to focus on that particular vertical. So they need to focus on the finance. If you take any healthcare provider like Apollo or anything, their main objective is to provide the services on a hospitality. So they don't have time or they don't need to spend much time on their IT infrastructure. So that's where they wanted to cut down the cost and they wanted to focus on their main area. That's where this cloud computing started booming. Because here, what happens in cloud computing, you don't have to worry about whatever I said here. Now, the data center, they don't need to worry about the data center maintenance or manage or capital cost or investing the time to buy the rack or buy the expensive servers. They can just use the services and pay for that one. Okay. So before I start on the cloud computing, I just wanted to uh, I just wanted to hear from you. Did you understand what is a data center? Why the companies are going to cloud computing? Guys, please say yes or no. I'm not able to hear anybody. There are 10 people. Hello, Amit.
Hello. Yeah, Kumar.
Yeah, I know. I'm not able to hear. Like, I'm not able to hear any. So I'm not sure.
Just a minute.
Okay, okay. Unmute option is not available. It's fine. It's fine. It's fine. There's somebody. Gautam has mentioned that unmute option is not
Yeah.
available.
Now
It's
I
fine.
can do it, so they can unmute and ask questions.
Yeah. Yes. Please. Please. Yeah. So I can share this slide with you guys. So you have any questions related to data center, please go through that. Then you'll understand how big is a data center, how difficult it is for us to maintain the data center. So now I'll just take questions on the data center. Please enable for them to talk, Amit.
Yeah, I am enabled to them.
Guys, please speak out.
Like I have understand the data centers.
Mm-hmm.
Mhm. And also like Microsoft also planning in underground
Ocean data center or ocean cable?
ocean data center.
Yeah. That is, but when you talk about the ocean cable, it is already there. See, okay. So whether it is Amazon or Google or any data center, so you see here, let me go back to our country, India. So let me bring, now you see here, this is India, right?
Yes.
Okay. Now see this, there are two gateways in India. One is in Mumbai and one is Cochin. Sorry, three. One is Mumbai, one is Cochin, and one is Chennai. So any traffic which is going towards the east, sorry, west, it will go from Mumbai. Any traffic that is destined for east, it will go from sorry, Chennai. So this is the underground cables. So you see, these are underground sea cables. They have the private network. So either it is AWS or Azure. They have a private cables which is only dedicated exclusively used for Azure or Amazon. So they go underground sea cables. So from India it goes to Dubai. So from there it goes to Black Sea, Mediterranean Sea to the Europe. So this is the Europe, right? This is Europe, and from Europe, something comes to Africa, and then from the Europe through transatlantic underground cables, it goes to US. So this is US, your US. See, then from the US it is to Japan. This is Japan, and here to this is Japan to on the Asia, so Asia Pacific, and then you have Australia. So every continent, every data center is connected with underground sea cable, which is AWS has its own underground sea cable. Azure has got its own thing. Here I'm showing Microsoft, but it is similar to your AWS also. So let me close that one. So we have 2D picture. So this is the existing AWS data center all over the world, right? You can see here, right? So in
Yeah.
India, we have two. One is in Mumbai. So in Mumbai, we have data center in 2016. We have Amazon data center, and in Hyderabad, we got it last 2 years back. So these are the existing data centers all over the globe, and the red ones are the one which is in progress. And one more thing,
Okay.
AWS will shut down some of the data centers without informing without informing to the public. But as of now, these are the data center currently available for Amazon. Okay, so this is one picture inside a data center where your application, whether your Skype or WhatsApp or Instagram application will be installed here, and you will be accessing through internet. Okay, so this is all about the data centers. So this is Amazon data center. Now, again coming back to my first slide. So here we are going to talk on the first class, what is a cloud computing, what are the deployment models of cloud and service models and so on. So anything, any question, please? I just want to take 1 minute for questions before moving on to the next slide. So everybody here, to understand AWS Solution Architect, this is high level, which I've already told. Now, first, what we need to understand is, now we understood sorry, data center. First, we need to understand cloud computing. So we are going to talk about. I'm really, really sorry. I couldn't able to hear anything, or I couldn't able to understand. The voice was little cracky. I mean, cranky. So I couldn't able to understand. Amit, was there any disturbance, or it was somebody was talking on the background?
Yeah, yeah, tell me.
No, no, no. I heard somebody was asking question. I don't know. It was by accident or somebody was talking in the background. So I'm just trying to understand that one.
Okay, okay. No, I have already unmute them, so they can unmute and
Okay.
ask questions.
Yeah. Okay. So now we have done what is a data center. Just a rough overview. I know I was a bit fast because I just wanted to. That was not the part of it, but I just wanted to give some understanding on DC. That is data center. When people tell DC, that is nothing but data center. So now Now let's see what is cloud fundamentals. What is cloud computing? Okay, first thing what we need to understand is before learning any of the cloud computing technologies, like either it could be AWS or Azure or Google or IBM or Alibaba, first we need to understand what is a cloud computing, what does exactly it is consisting of, why it is so important for the business development. Nowadays everybody is talking about the cloud, why it is that. So what is there, it is there newly or it was there from the beginning. So we are going to understand that one. Okay. And who should take this course? That means the cloud computing fundamentals. So here I'm not talking about the AWS, I'm talking about the cloud computing. So anybody who wanted to learn or know about the cloud computing, whether they have the basic knowledge or whether they don't have any knowledge, they can take up this course. Or somebody who knows little bit of cloud and they want to learn more, they can take this course. Okay. Or you are from a different background, you are a Java programmer, you are a system administrator and you want to move into the cloud, then you can take up this course, this module. Okay. So what are we going to cover? Here we are going to cover what is cloud computing, what are the deployment models, what are the concepts and service models. These are the four things that we are going to cover, and some of the examples of cloud computing. Okay. So what you will gain on completion of the course? So you will have complete idea on the cloud computing and key concepts, and it will also allow you to determine what model that you need to use or what services that you need for use for your organization. Tomorrow, if your company comes and asks you, I need this one in the cloud. So after this course, you will be in a position to identify which model to be used or which services. If you're using one model, and on that model, what services you can use it. So you will get very comprehensive idea on this one. So start off, what is a cloud computing? What is cloud computing? So before that, I wanted to show something. So the global market, you can see the projection like in 2024 it was 722 billion, and in 2025 it is 86868. So every year on global market, it is increasing at the rate of 16 percentage. So you can see that there is no diminishing. It is always cloud computing projection is always very high. This is on global level. Every year it is increasing at the rate of 16%. And when you talk about the India, it is increasing at 35 percentage. I still don't have the data on 23. So till last before year, it was increasing at the 34 percentage. So what I mean to say is learning cloud is always will be beneficial for your career advancement. Now everything is moving on to the cloud, one or the other way. So learning cloud will definitely will help and sustain you in getting your futures. Okay. So we will see what is a cloud computing. So here you can see red color and green color. So I'll explain in that one. What is a cloud computing definition? It is a remote virtual pool of on-demand shared resources offering compute, storage, database, and network services that can be rapidly deployed at scale. So what is this means? Compute, server, storage, database, and network services you can use and you can deploy at fraction of minutes at a scale. At a scale means at a large. That means if you take about one server, you can install the servers from one server to thousands of servers in a minute at any given point of the time. So that is the meaning of this one. Please understand one more time I'm saying is that you can install server or storage devices or database or network services at any, there is no limitation. You can install any at any given point of the time. Now, if you understand that, then let me go back to this red one. What I mean by the red one is remote virtual pool of demand services. That means whatever the services that I'm offering to you, the cloud provider, will not be a physical, though those all will be virtual services. That means I'll just give, so we are going to discuss if this is the server, EC2 server, okay? I think some of the people know what is EC2. If I'm giving EC2 to one of the, this is my physical server. So what in physical server, virtual, remote virtual means this is one physical server. Yes, please say yes or no.
Yes.
Okay.
Yes.
Now with the help of virtualization, I will make it. So now I make it as a four servers. Is it clear? Now, this physical server I can give to customer A, this I can give to customer B, this I can give to customer C, and this I can give to customer D. When anybody, like customer A, when he tries to launch the services EC2, he'll be getting the virtual server, not the physical server. That is what the meaning of a remote virtual. Is it clear? Ba-
Yes.
Okay. So in virtualization, how do I give in a real-time example? I'm just thinking. Uh, Okay, the other beautiful example I can give is when you buy your laptop or laptop, when your hard disk is corrupted, you replace with a new hard disk, 1 TB, 2 TB, right? When you get it, so what you'll do, you do the partitions, right? C drive, D drive, E drive. Is it right?
Yes.
So C drive you give 100, and for D drive you give 400, and for E drive you give 500. So what is this partition? These partitions, physical partitions that is you doing, it is a virtual, right? It will be everything on the single does a single 1 TB hard disk, right? The hard disk will be same. On that one, you are doing a partition so that C will have separate partition, D will have separate partition, E will have separate partition. But the underlying hardware will be 1 TB only, right? So from where you are getting this 100 GB, 400 GB, 500 GB, the partitions that you are making, the partitions that you are making is from your hard disk only, right? 1 TB, whatever you brought. Yes or no? So same way,
Yes.
in same way here, one physical server, by doing a virtualization, you can partition that and you can give to different customers. Customer A will not know that he's using this server, or customer C will not know that A is also using this server. And the capacity always depend upon the underlying hardware. Like for example, here my, if I am doing a three partition and which is a 1 TB, I cannot give 300 for C drive and 600 for D drive and again 500, because it is exceeding my capacity. Whatever the partitions that I am doing, it should fall below the my physical capacity. Same way here, when you are dividing the servers, it should be always inside of your physical capacity. Okay, so that's why I'm saying whether you take storage services or database services, network services, these are all not the physical services, these are all remote pool of virtual servers. You can use it, that can be deployed very fast at a very large scale. Okay, so other thing is, other definitions, on demand delivery of computing resources over the internet with a pay as you go pricing. That means you use it and you pay for that. The advantage is, instead of buying, owning, or buying or own that one or maintaining a physical data center, you can just rent those services from the provider, cloud provider, and pay for the usage. Other logical example I give, we all need electricity, right? Since we need electricity, we don't go and buy, we don't go and like manufacture, not manufacture, we don't generate power, right? We take it from the supplier, we use it, and we pay for that one. Same way here, cloud computing, whenever you want, You take the services, whether it is AWS, Azure, or Google, and you have to pay for the amount of the time that you have used it. Now I'll give the standard. There are different definitions for cloud computing. So let me take one definition which is of NIST. NIST is National Institute of Semiconductor Technology, which is standard body like our ISI, that is globally accepted. Okay, so this is a definition. So whenever somebody asks in internet, so this is the easy definition to tell: on-demand delivery of services, but this is more of a technical service. See here, cloud computing is for enabling ubiquitous, convenient, on-demand network access to shared pool. Again, shared pool of computing resources. Shared pool of computing resources, what are those? It could be a virtual network or virtual servers, storage applications that can be rapidly provisioned, means that can be installed fast, and after the usage it can we can release. So whenever you wanted some servers, you can implement it, and whenever you don't want, you can terminate it without asking permission from the provider. You don't have to request the service provider saying that I need the server, I need the storage devices. You want it, you turn on, and the moment you're done, you can close that one without interaction of the service provider. Okay, so this is the definition. Now I'm coming here. Ubiquitous means, like, anybody knows what is this meaning? Ubiquitous means anywhere, anywhere in any part of the global, convenient, easy, on demand network. That means anywhere in the globe, you- anywhere in the globe, anytime you wanted to have the resources, it should be available to you. So that is the meaning of the first line. I'm somewhere in Amazon forest and I wanted to use a server, it should be available for me. The provider should be able to provide the services for me. But here, only one condition: as long as I need to have an internet connection, I can get connected to cloud providers. Is it clear?
Yes.
You can
Yes.
access cloud computing not only through your laptop, you can access through your mobile phones, you can access through your tabs, or you can access through desktops. As long as you have internet connectivity, use them, the device connect to that, and you can turn on servers.
Like the data centers, beyond the data center will provide the cloud access.
Ye- No, no, no. See, data center. See, when you're talking about the AWS, it's a data center. So you have to
Yeah.
log into their console, and you want the servers, you can spin up the servers. Data center will not come in between. It will give a it will give a tool like console web access. All is that you need to log in, register yourself, and use that, and you pay for that. That's what I'm saying right
Okay.
here. That's it can be provisioned and released with a minimal effort from the service provider. You will not interact with AWS only. Only when a billing related issue is there, something technically, then you will send it, you will raise a ticket with them. Otherwise, you don't need anybody.
Okay.
Okay. So I hope the definition is clear for everybody. So
Mm.
whatever the resources that you use, it is not physical resources. You are using a part of physical resources. Okay. Now let's go one step back and understand the cloud computing. This kind of on-demand delivery of services and all those things was there from not just from the last few years. It was there from very long time, but then every company was having a servers database and all things. They started claiming themselves as a data centers, cloud computing providers. Then NIST came and proposed a solution or given a framework saying that the data centers or the cloud providers should always, when you want to claim yourself as a cloud provider, you have to have this definition. That means anytime, any part, anybody can access your services, and the services can be deployed at any given fraction of time. So only when you meet this requirement, you can call yourself as a cloud provider. See, for example, tomorrow I have 1,000 servers and I cannot claim myself as a cloud provider because if somebody tomorrow comes and asks me, I need 2,000 servers, I cannot provide. It's just that because I have 1,000 servers and a huge space, everything, I cannot claim myself. So that used to happen. Then NIST came and said that no, this is the meaning of ubiquitous on-demand delivery of IT resources over the internet. Only when you are able to meet those requirements, you can call yourself as a cloud provider. Now, why there is so much of cloud computing buzz is happening, why companies have started using is because of the virtualization. Okay, so what do you mean by virtualization? Virtualization is having dividing your physical mission into multiple missions. Okay, here you see on the right hand side, this is my laptop or desktop. Okay, what I'm doing is here it could be what I say 8 GB RAM and a CPU 128 CPU and 250 degree of hard disk. CPU, what is 16 CPU? 16, okay, 16 CPU. So now what this hypervisor will do, hypervisor is software. So please, let's not get into deep of virtualization. Let's try what virtualization does. So virtualization is a piece of software which divides your hardware into like multiple virtual machines based on the underlying hardware capacity. Now it can do using this software. In this example, this software divided into three virtual machines. Okay. Now here, what is the other advantage is here you can have only one operating system. Tell me your laptop or desktop can have multiple operating system. You use only one operating system, right? Windows or Mac, right? But when you have a multiple missions, so it will treat this as a separate mission, this as a separate mission, this as a separate mission. Here you can run Windows, here you can run Linux operating system, here you can run Unix operating system. So three missions, you are using three different operating systems.
Merry Christmas.
Okay, definitely.
Happy Christmas.
So
Nice Christmas.
hardware, shared hardware, it is achieved by hypervisor. So hypervisor is a software used to
Bye.
create virtual missions.
Invoca Christmas.
Okay, the hypervisor is the one which acts as the interface between your physical actual device and the virtual machines. So any request that has to VM has to go, it has to go through hypervisor, then through the hardware. Okay, clear? So here you can see this guy is working on one hardware through the help of virtualization. He was able to. So this hardware will have CPU, RAM, and operating system, right? Storage. So with this virtualization, he was able to create three virtual machines. It's not just three. We can create as many as uh, y- your hardware based on your hardware support. If your hardware is supporting more than 5, 10, you can use that one. You can create those many guest machines, those many virtual machines. So, like, we don't need this slide. Just I wanted to understand, make you understand what is virtualization. So, why we need cloud computing? Say companies spend a lot of time on the infrastructure, buying hardware, software, and maintaining them, the space, electricity, and all whatever I discussed. So these everything whatever we the infrastructure hardware operational thing and people personal technicians everything will be managed by provider so that we can focus on our main business. It could be whatever the main business, export import or pharmacy or anything, we can focus on our main thing, and the IT related things we can get it from cloud computing. So making quick changes to application as per customer requirement and faster deployment, that is possible with cloud computing. So what I mean to say is, if tomorrow your application is serving 1,000 users, but just imagine if tomorrow like you need to serve 10,000 users, then you need an additional servers. To get additional servers at your premises, it takes lot of time. In real time, to get one server into your network, it takes 2 to 3 months. But with the help of cloud computing, you can deploy multiple servers within fraction of minutes. Okay, so that is one thing. Okay, so any application or any programs requires the backup, right? So here, backup in real time backup software is very costly and you need experienced people to do that. But here, anything related to backup or licensing or anything related to your day-to-day operations, everything will be handled by cloud computing. I mean, cloud providers. So, so you use the services and you pay for the your usage. Okay. So these are the important concepts in the cloud computing. That is, when it comes to our AWS solution architect, we need to focus more majorly on cloud, sorry, compute, storage, database, and network. So machine learning and artificial intelligence, we are not doing anything on that at this point of the time. So the majority of our focus on this program will be compute, storage, servers, and network. Okay. So compute is nothing but it will provide processing power like our server, our systems. It will have CPU, memory, storage. Storage is the storage devices like our hard disk or USB, where we'll store our data. There is separate section for compute. There is separate section for storage. So when we are going to talk about the storage, we are going to talk about in detail direct attached system, storage area network, network attached storage systems. This we are going to see the differentiation, and then only we are going to talk about the storage. See, database. So to store your data, then there are three types of database. I said SQL Server, Oracle, MySQL. So we are going to talk about SQL Server in our AWS. The network, we have different firewalls, routers, switches, which because we need communication between different servers, different applications to inside to they need to talk to outside world and the outside world need to access our services. So those all things will manage in network. So again, this is a definition. So before I go to deployment models, I wanted to stop it here and I want to take the questions. Amit, you can unmute.
Actually, how many days it's taking for learning?
See, it takes usually AWS recommends 45 to 50 hours, but now you see, right? Like now we don't have to discuss. I mean, it was not necessary for me to explain on the DC things, right? So there are sometimes like I go beyond the scope of the syllabus and I'll try to give a background of that one. So, but ideally it should take 1.5 months to 2 months, 45 to 40, anywhere between 45 to 60 hours.
Yeah, okay.
So, any other questions, please? As I said, let's not very strict with the timing because there could be the some reasons where we have to go beyond AWS syllabus to learn the basics. Just to give an example, like when we talk about here, like can you see my screen now?
No, I guess.
So can now see here when you're talking about the storage, like AWS directly start with their services S3. But before that, we need to understand what is direct access system, storage area network, network access system. So I take 1 or 2 classes to explain these different storage technologies. Then I go with the storage services. So those 2 classes will not be extra from our AWS. So because I wanted you to understand the concept, then the services of AWS. Okay, so I'll give you another minute to take the questions. Otherwise, we can wind up our session for today, and you can guys can get in touch with Amit for further details for the next class, or how do we want to proceed further. I hope now you guys got a fair amount of idea on what is a data center, why the companies are spending more on the cloud computing.
Um, Hello.
Yes.
Just wanted to know, like, not related to whatever you discussed. It's very clear and uh, I mean, well described. Just wanted to know, is this a course or what? I mean, how these are planned? Like, is this a free course or a paid course or what is this?
No, this is
I
a
just
paid
got,
course. No,
yeah.
this is a paid course. Like it's of
Mhm.
60 hours, 40, 50 to 60 hours, wherein we are going to
Uh,
talk about each service, each model, each services, what is that,
mhm.
why it is, where it is, how we need to use. Okay. So
So,
not from the theoretical point of view,
mhm.
we'll learn how and where we need to use those services.
Yeah, I mean, what are the details? How can I get the details? Like, how the course will go further, and what is the cost of this course?
I think Sarkar, right? Like you can get in touch with Neil or Amit. I think those are the people who are coordinating with you, right?
Yeah, I mean, I got a link from LinkedIn from someone, I believe Amit or someone,
Amit,
Ajit.
yes, Amit,
Yeah,
Amit,
and
Amit.
I joined through this WhatsApp link, but I do not have any further details regarding this. So I mean, I just wanted to curious to know, like, what are the details. If somebody can give the details in WhatsApp, that will be
Okay,
great.
so let me open. Amit, you there on the call? Amit?
Hello. Yes,
Amit,
Saran.
yeah, yeah. So the people are wanted to know on the further details. So they wanted to know how to reach or how to proceed further.
Yeah, I will
Uh,
share the numbers. Everybody has my WhatsApp numbers, so I will ping to him here. Just text me, so I will share the course content, so we can plan according to if it is weekend batches or there is weekdays batches, we can plan according to it. Okay.
Is there anything, any brochure or something like you have? You can share it in WhatsApp. That will be great. Before talking to, we can see that what are the things we are going to.
Okay, you're talking about the contents?
Yeah, any contents, anything, and the course fees or things
Yeah,
like
sure,
that.
sure. I will share in your WhatsApp numbers.
Yeah,
Yeah.
yeah, that will be great. Yeah,
Okay.
thank you.
the course content, it would be as per AWS prescribed, Amazon prescribed. So the price and the duration and all, Amit will
And
get back to
and
you.
one more question, like, you conduct exams also, or it's just a course?
It's course like exam. It's again, it's an online exam that you
Mm-hmm.
have to register yourself in any Pearson or a Pearson testing center,
Mm-hmm.
and you have to pay I think $150, and you have to take an online test, and you will
Okay.
get certified from Amazon.
Okay. So you are not conducting exams.
N- No,
Okay.
no, no, no. We are not authorized. I mean,
Yeah.
Amazon will have
Mm-hmm.
a partnership with the Pearson, so they are
Mm-hmm.
the one who conducts the examination for all Microsoft, Amazon, Google, or any other like project management or
Yeah.
anything. They are the vendors.
Yeah. Yeah. Got it. Got it. Got it. Yeah. Thank you. Thank you.
Yeah. Okay, guys. Then if nothing is there, then I will appreciate your time because it's your weekend. You took your time to attend for this, and thanks for your patience for listening to me for last 1 hour.